Morning everyone, and thank you for watching my talk about building a secure Python cloud application from scratch. I hope that in the next 20 minutes, you will be able to grasp the basics of which threats you're facing when you're writing a Python application hosted in the cloud. You will also get some concrete action items in order to monitor those risks from the day you're starting to build your application. If you have any question during the talk, feel free to send it through the chat. The slides I'm showing will also be available at the end of the session. But first of all, I would like to thank the PyCon organizers for letting me share my experience with you. Even with the limitation of being virtual, they managed to create such a great event with a fantastic panel of talented speakers. A quick disclaimer first. Cybersecurity is a critical but very wide topic. This talk doesn't claim to cover everything even briefly. If you're looking for a deep dive session on threat modeling and cloud security, there are a lot of resources online. The goal of this talk is more to describe the attack surface your application is exposed to and to give you some recommendations you can implement today. I will also show you a demo of a real tiny application in order to give you a more concrete example. But just before diving into our subject, I would like to introduce myself a little bit. I am passionate about technology in general and involved in the cybersecurity field for a few years already. Besides my PhD in bioinformatics, I worked as a full-stack engineer in the city office of CloudOak and Cisco, where I helped building cloud applications at scale and led some strategic projects. I'm now the co-founder and CTO at Seabriggs, a cybersecurity company still in stealth. I was also involved in a few communities in the last couple of years, as I find it very rewarding to share knowledge and experience. So when should you start to care about security? I'm sure that it's usually not the first thing that comes to mind when you start building a new application. But if you're not baking security in the design of your application, chances are very high that along with your first lines of code, you already start to gather security debt, and that you'll always be behind. If I was to ask some engineer what is his main concern when writing his application, he would probably mention functional bugs and performance way before security. And that's also the way startups are picking up their priority. You need to deliver business value in order to survive, accepting the risks of security at least until your customers start asking about it. That's mainly because security is hard and it's an ongoing concern. It's not something you can deal with once and take a checkbox. It's a journey and a continuous investment, but its cost is lower if you start managing it on your first day, not necessarily taking actions, but at least be aware of what needs to be done so that you don't spend your time catching up. But what is the attack surface of a typical cloud application written in Python? Well, here's an example. It's a serverless application which includes an API gateway to expose a basic REST endpoint, a simple Lambda function that holds the basic business logic, and a Postgres database provided by AWS as a service for persistence. The code of this application is stored in a Git repository at GitHub, and the CI/CD system, GitHub Actions, is deploying it to AWS. Now, if we're looking at the map of the risks here, we need to take into account all the places that have an interaction with the application code. It starts on my local laptop, where I write the code in my IDE, and then on GitHub, where the code is committed and stored, and then in GitHub Action, which deploys my code, and finally in AWS, where it runs. Risks are mainly tied to either stealing some secrets, like API keys or the code itself, tampering with the code by injecting some malicious content, or compromising my AWS account in order to either steal some data or leveraging my cloud resources for Bitcoin mining, for example. So how can I monitor these different places in order to mitigate those risks? Well, each area and each risk has a different type of control. It starts with the endpoint protection, or in other words, my own laptop. And then you have the code scanners, like secret detection or static code analysis tools that run on the code in order to find some vulnerabilities. Software component analysis, or SCA, helps finding vulnerabilities in the dependencies. The CI/CD system usually has its own built-in controls like MF enforcement and audit log, which allows admins to monitor suspicious activity. And finally, for the runtime environment, there are dynamic scanners that can test that my application API security is configured correctly. And in addition, there are some native cloud controls like AWS Security Hub or Macie that are respectively monitoring for vulnerabilities and sensitive data in S3 buckets. Here, we have a more exhaustive picture of the various insertion points along the software development lifecycle, which includes, in addition, for example, artifact scanners, which are relevant for binaries and containers. Let's now get to some concrete recommendations. In order to do that, and for the rest of the talk, I will take a real example of a serverless Python application that I will deploy using the serverless framework. GitHub will be the service I will use in order to store my code, as well as the one that I will use for my CI/CD pipeline. All the examples I will show in this talk are available in the following public GitHub repository. So let's start with your own laptop. If you're building an application, you certainly have some secrets. Don't store them locally in plain text, either in some .env file or even in your bash profile. Any malware that would be on your system could steal those secrets. Use a password manager instead. That will help you both for sharing those sensitive values with the rest of the team and also for injecting dynamically those values in your script. If you're using 1Password, they have a great CLI tool you can use. So no need to save the GitHub SSH key in a file. You can add it dynamically to your SSH agent using the command below. Here, for example, I added the SSH key into a secret note, a secured note, and I'm retrieving it from my private vault, dynamically adding it to the SSH agent. Same thing for AWS credentials. Instead of saving them in plain text in your laptop, you can use a tool like AWS Vault in order to dynamically load them into the AWS CLI. Now, obviously, if you should not store your secrets in plain text in your laptop, you should also never commit them into your Git repository, but it may occur inadvertently. Remember here that once committed and pushed, you cannot simply remove the secret from your Git repository by deleting it, because Git stores also history. So make sure you use some secret detection tool as part of your pre-commit hooks, and of course, as part of your CI process. Let me show you how you can easily integrate Detect Secrets, a tool developed by Yelp to detect secrets as part of your CI pipeline. A lot of plugins exist to detect all sorts of secrets like GWT token, AWS and Azure keys, basic auth credentials, and so on. So here is an example of a GitHub Action file. It starts with some basic setup. We're using an Ubuntu latest, and then we're checking out the code and setting up Python. And finally here, we're installing the Detect Secret package from PyPy, as well as JQ for JSON processing. We then run in this step the tool itself and outputting the results into a JSON file. The next step here is crucial in order to detect whether or not there are some secrets that were found by the tool, and if so, just fill the whole job. And finally, in any case, we're uploading the report as a GitHub artifact. Now, in addition to scanning your code secrets, there are all sorts of vulnerabilities you want to detect as soon as possible. For a list of the most common types of vulnerabilities, I would recommend taking a look at the yearly list compiled by the OWASP organization. If you never heard about it, make sure to watch the talk by Ronnie Shear later today related to OWASP Top 10. A few code scanners exist for Python, and I will show you now how to integrate Bandit, a tool written in Python, to your CI pipeline with a few lines of code. But before that, here's a list of the vulnerabilities that Bandit is detecting. For example, the version of your SSH client. So this is the GitHub Action file that is required in order to integrate Bandit and to run it on your code. The same usual setup with checking out the code, setting up Python, install the Bandit package using pip, and then we're running the tool itself, outputting the results into an HTML file. In this case, we don't need to do any further processing because Bandit is returning an exit code of 1 if it finds something. And at the end, as usual, we're uploading the report as a GitHub artifact. Now, in addition to scanning the code, major risks also lie in your package dependencies. Over the years, multiple incidents have made the news with the more recently SolarWinds use case. In the Python ecosystem specifically, malicious and vulnerable libraries have been discovered from time to time in PyPy, and it's highly recommended to scan your packages for known vulnerabilities against a database of packages that is up to date. Let me show you now how to integrate the OWASP project dependency check, which also supports Python, though experimentally. So this is the GitHub Actions that we will use. It's a little bit more complicated than usual. You'll see why. First of all, we'll do the usual checkout of the code and the setup. Here I'm also adding Go because I will use a package called pup in order to process my HTML report. I'm setting up Python, and here I'm also setting up some virtual environment because I will need to install all my dependencies. This is what happens here with the pip install of my requirements. The second part of the file will do the following. First of all, we add a step to cache the dependency check database. That's because I don't want to download it every time this job is running. I will only update it once in a while. And then I'm installing the dependency check package, and I will run the command using the enable experimental flag. The results will be in HTML, and I will add some file to suppress some checks that I don't want to, that are more false positive than something else. Finally, here I'm checking the results. I will look for a specific ID inside my report, vulnerable count, and if it's more than 0, then I want to fail the whole job. And at the end, I will, of course, upload my report as an artifact. Now, once I'm done with the code itself, let's take a look at what happens with GitHub, the place where I'm storing my code. This is a thorough analysis of the risks that are associated with GitHub. It provides a variety of services in addition to store the code, like building and scoring artifacts and running CI jobs. Based on what you're using, you should be aware of those risks and adopt the best practices. And here's a few. Enforcing MFA for your organization and branch protection for your repositories, reviewing their base permission, as well as any third-party access. And finally, analyzing your audit log for suspicious activity. For your CI/CD system, besides enforcing MFA like for all your SaaS, you should also monitor your third-party plugins. Those can be real plugins that you install like on Jenkins, or open source actions that you can call like in GitHub Actions. Check the user permissions and follow the least privilege principle. And as usual, monitor your audit log for suspicious activity like failed logins. Here I'll show you how to easily check your GitHub security using GitHub Actions, and more specifically if all your users have MFA enabled. For that, we have a simple GitHub action file that will leverage the GitHub script action that is provided by GitHub. It gives us Node client for the REST API. We also use a token here that has read access to my organization. And basically what the script here is doing is listing all the members of this specific organization, filtering only the ones that have don't have MFA enabled. Here we're printing the results of this filter list. And if this list has more than one member, then we want to fail the whole job. Finally, the runtime environment. So basically your public cloud in this case. The number of risks really depend on the number of accounts you own, the region you operate in, and the services you use. Regarding specifically your application, you should use a DAS tool that dynamically scans the endpoints that your application is exposing. And now I will show you how to use Zap, which is an open source project. So here you have a diagram of what I want to do. Basically, you have your application, which is composed of a Lambda function and an API gateway. I will deploy that using serverless framework to a local stack, which will simulate my AWS environment for my CI system. And then I will use Zap in order to call the endpoint that my application is exposing on port 4566. For that, let's take a look at the GitHub Action file. First of all, it also runs on Ubuntu. It uses services, so a container that will give me access to local stack. So this is the image of local stack, where basically I'm enabling a few of the serverless services. I have also my health check here to make sure that I'm not trying to run a job before my services are ready. Once it's done, I'm checking out my code. I'm setting up a node, installing serverless framework, and will deploy it to local stack using the local stage. Finally, I will retrieve the URL of my application using SLS info, and I will use that as an input for the Zap action that is provided by Zap itself. This will automatically fail the job if it finds some vulnerabilities, as well as opening some issues in GitHub. And it will also upload a report automatically as an artifact. Well, now I want to show you how it really looks like in GitHub. So this is the repositories that you have all access. It's a public repository. You can see here the application itself, here into the function. This is my handler. This is a very, very simple handler that basically returns the current time. Here we have the serverless manifest that will allows us to deploy that to either AWS or to local stack. And now let's take a look at the GitHub Actions. You can see here that I have two types of workflows. One that is triggered by push events, and the other that is triggered by a schedule. Let's take a look at the push first. So this is the last run. You can see that I have 4 different types of checks. The detect secrets that we showed previously, the static analysis, so that runs Bandit, the dependency check using the OWASP project, and the dynamic analysis for Zap. In this specific case, there is some issue with dynamic analysis that has been found, and we can see that into the issues. This is the report. We can see here that we have some cross-domain misconfiguration, for example. CSP header is missing. We have all the details here. Now we can take a look at what's running on schedule. And here we can see that we have the MFA checker. Let's take a look what happens here. We can see that we have 2 users that don't have MFA enabled in my specific organizations. Of course, for all these different checks, we can also verify that we have here we have here we have the artifacts. Let me take a look at the artifacts on the push. These are the artifacts for bandit, for the dependency check, for the detect secrets, and for zap. So as you can see, it only took a few lines of code to add some basic security to your application, and you should start doing it today. Of course, things are not over yet, and the journey has only begun, but it should already give you some good basics. If you like what you saw, then you should know that at Seabriggs, this is our mission, helping engineers own security. We want to automate and abstract security so that it becomes obvious and not time-consuming to include it when you start your next project. If you want to join our venture, we're hiring right now. And if you're a security champion or are interested to know more about us, feel free to drop me a note. We'll open a beta program soon. Thank you again for your attention.